So welcome everyone. Today we are going to solve another interesting problem which is titled as container with most water. So let's try to understand the problem statement. So you will be given an integer array named as height. So this is nothing but representation of heights of different walls. As you can see, the first element corresponding to a wall, vertical wall, which has a height of 1 unit, and 8 another wall which has a height of 8 units. Similarly, all the other walls. And the objective of this particular problem is that what could be the container we can decide with such vertical walls which has a capacity to store most amount of water. I will try to explain. For example, if you take these two walls as the end points of a containers, so this particular region will be the area of the container, because if you pour more water above this particular level, it will overflow. So up to this much unit area of water can be stored. But if you have chosen this and this as the end boundaries of the containers, then this much amount of water it could have stored. That is the one thing, because once it is over than this particular height, then it will overflow. So how can we find that? Like, what could be the container with most water and what is the quantity of the water? One thing is that we can generate all the possible containers. For example, first we can generate this, then we can generate this much, then we can generate like this much. So as you can see, among the two boundaries of the containers, what would be having the minimum wall height, that much height will be the water level. And similarly, internally, if you like made a container like this, so this is also one possibility. So there can be multiple possibility. So one way to approach is by brute force. Brute force approach would be like fix a pointer here. For example, let this pointer be I here, and let the j would be here, and we can traverse j. Then once one particular traverse is complete, then we can update I, then again traverse j from next point, like I plus 1 point. Like that we can do. Like that we can calculate all the possible containers we could have designed with the given information. So in that case, I would be ranging from 0 to n minus 1, and j would be ranging from I plus 1 to n minus 1, like back to back loops. So in this case, the time complexity of this particular approach would be of the order of n square. Space complexity, if you write it properly, we don't have to use any extra space, that would be order of 1. So I am not going to code this brute force. Let's think about, is there any efficient way that we can optimize it? And it turns out that there is a way to optimize it. So let's try to understand that particular approach. For that, what we are going to do, we are going to approach something very similar to like what we are applying in binary search. So we fix a pointer, like let's call, for easier for explanation, let's fix the pointer here as left, another pointer here as right. And then what we are going to do, we are going to calculate the area enclosed by the container where we can decide using this particular point. For example, initially if this is the case, the area is going to be nothing like this shaded region. So let's see how we can calculate this particular area. So this area is nothing but, area here is nothing but width into minimum among the, what, let, if height is the array name, minimum among height of left or height of right. So how can we calculate width? Width is nothing but right minus left into the same thing. So like that we can calculate area. And next thing is, how can we move the pointer? So we will move the pointer of left to next location if height of left is lesser than height of right. In that case, you would be moving the pointer of left equal to next location, else we will be reducing right. And this will keep on happening until left is lesser than right. So that is the simple idea. So with that we can efficiently do it without going through all the possibilities of the containers. So let's try to code it. So let's see how we can solve it. So this is the class solution, and the method inside the class is define max area self. Let's try to write the arguments. The height is the array which is given, which is nothing but list of integers, and what else is given? Nothing is given. We have to just return the most, like, container with most amount of water. That amount of water is what we need to return. So that is nothing but integer. So let's start. So left comma right is nothing but left is 0, right is length of height minus 1. So we have assigned the pointers. Now let's try to, like, initially let's fix maximum area to be 0. This is what we need to update later. Then while left less than right, in this case we can calculate the area. For that we need width. Width is nothing but right minus left, and height is nothing but minimum among height of left comma height of right. And we need to update maximum area on comparing with existing maximum area, like maximum between existing maximum area and the width into height. So like that this will get updated. And next we have to think about how to move the pointers. If height of left is lesser than height of right, in this case we need to move the pointer left, else we need to move the pointer right by reducing 1. This keep on happening until the while loop get exhausted, and at the end we just need to return the maximum area. So this is how we can efficiently solve. So what is the time complexity here? Here the time complexity is nothing but order of n by 2, because both the pointers are going to converge somewhere in the middle, so it can be n by 2. So we can approximate to n. Space complexity, we are not utilizing any extra space, so that would be order of 1. So that's all about this particular problem. I hope you understood. Thank you for listening.